me change this. All right, it's going on page 25 and we're done. And that is too wide. All right, so we're going to start with a pretty basic review. I told you that, we kind of weren't sure exactly what was going to happen this week, so we're starting pretty basic, but that's okay because we're going to talk some about notation. And having the correct notation is hugely important in anything you do mathematically. So we're first going to talk about relations and functions. So are relations and functions sometimes the same thing? Yes. If you have a relation, can it be a function? Yes. Are all relations functions? No. Are all functions relations? Yes, they are. Okay. So we're just going to talk about relations first. So basically, one way to talk about relations is just that it is a set of ordered pairs. So it is how does, x relate to y? Something similar to that. So it could look like this. 0, -2, 3, 4, 7, 12. Okay, I go from being too thin to too fat, so we'll see how that works. Okay, so just a relation of the two coordinates. All right, so here's a few different ways to represent them. The first way could be a table. So I could have 5, 6, 7, 8, and -3, 2, 0, 4. It's relating x to y and whatnot. I could have this here and have like -5, -3, 2, 0, 1, 2. And then say, all right, well, 5 goes with 2, -3 goes with 1, 2 goes with 0. Does anybody know what this representation is called? Nobody's known all day, so that's okay. I'm just curious if anybody knows. I don't even know if they tell you what it's called, but you've seen it, right? Even if you don't know what it's called. This is called the mapping notation. Because -5 maps to 2, -3 maps to 1, 2 maps to 0. Or I could have a graph. Or I could have an equation. So when we have relations, we can find things such as domain and range. So who wants to explain to me what domain is? X, okay? So basically that's kind of what pops in your head first, right? Domain is X. So does it always have to be X, or could I say it's A? I can, right? So what's another, X is good, I'm not saying it's wrong, but what's another way to refer to that variable? The input variable, okay, which is another word for that is what? Independent, good. So the domain is the set of all possible X or independent values, which is also like the input value when you think of a little function machine, right? It's what you input and then the other is what you get out. So the range then would be the set of all possible what? Good, dependent, y or dependent values. So this is not only a review from Algebra 2, but really from Algebra 1, right? In order to do domain and range, we have different types of notation. So over here in this blank column where it says examples, we're going to do the different types of notations. And I wish I had gotten rid of that word, and I didn't. So we'll just mark that out. We do types of notation. Because you should have learned all three kinds. And we use more than the one more. We use one more than the other, and one we don't really use at all anymore. But we're going to just start with a simple parent function of a quadratic. And we'll start by looking at inequality notation. which is most likely the first thing you learned when you learned notation for domain and range. So domain of this, now what's my smallest x value for this parabola? Negative infinity, good. And since it's inequality notation, I use the inequality sign. We're talking about the x's, and then my largest one is infinity. Do I make this less than or equal to? Do I include it? No, okay, because infinity is not a number, it's a concept of a number. You can't count to infinity, not because you'll run out of time, but because you'll never get there. Once you get to infinity, there's infinity plus 1 and infinity plus 2 and infinity squared and so on and so forth. So you don't include it because it's not an actual value. So then range, it's my smallest y. 0, so it's inequality of the y. Do I include the 0? Yes, it is part of that set, and then that is less than infinity. So I expect that you understand what domain and range is. You can find it, especially on super simple stuff. You know the different types of notation. Make sure you know what they're called, how to identify them, and if you're told to do it in a certain way, that you're actually using that one that you're asked to use. So then we also have set notation. So, oops, for domain, how can I just talk about the set of numbers that represent the domain? What are they? Okay, yes, but how can I talk about them as a set? What numbers does that include? All real numbers, good. So the domain then is just all real numbers in set notation. The range gets a little bit weirder because it's not all real numbers, right? But since it's a set notation, we have the little squiggly for the set. It's all the y values such that, what has to be true about y? Okay, greater than or equal to 0, good. Such that y is greater than or equal to 0. So this is what the set notation is. Here's how you read it. Y, it's all the y values such that y is greater than or equal to 0. So it's a little bit more complicated to write when that's what we're intending. This looks a little bit nicer, but then you have to make up for it with that. All right, then we have interval notation, which is what we will use the most. Interval notation uses the same kind of pieces that the domain or that the inequality does, but we make it look a little bit different. So for the domain, I'm going from negative infinity to infinity, but I use a comma here. And what goes on either side here? Okay, brackets or parentheses, what goes here specifically? Parentheses, because we're not including it, yes. So what can be confusing about interval notation sometimes? Okay. Yes, good. Both of those things. Whether to use brackets or parentheses, and it can look like an ordered pair. Here, not so much, because you're not going to go and try and plot that point, right? But if these were actual values in here, it can look like an ordered pair. So is that a point that I plot, or is it a domain? I don't know. And you do know based on the context of the situation. But at first, when you first learn that, it is kind of weird, like why couldn't it be different? But that's the way it is. All right, good. So then the range, I'm going from 0 to infinity. So what goes over here? Bracket, because I am including it, and then here is parentheses. So the three different types, you need to be able to you need to be able to read all three types. You need to be able to write all three types if you're asked to do so. Set notation, we're not intentionally using it all. And I say intentionally using, meaning it could show up in a question, like you have to be able to read it and use it that way, but you're not going to be writing it in that format just because you don't use it in calculus at all, because you don't talk about the stuff that way. Inequality we'll use a little bit, but really most everything is going to be interval notation, okay? So let's look up here. Now, when you have a finite set for domain and range, then it really is set notation when you're doing that. So like here, these aren't any things that I could give you an interval about, so it ends up being little sets of numbers. So it says, give the domain and range of each relation. So for the domain, what's my smallest x value? -5. So go -5 and then -1. Then 3, then 7, right? So then the range, I look at my y values. What's my smallest y value? -1. Now it shows up twice. Do I write it twice? No, I do not. So -1, and then 0, and then 4. Okay. Then on number 2, The domain, my smallest x is here, so -3, right? And then -1. Then 1 shows up twice, but I only write it once, and then 2. All right, so what's my smallest y? -4, good. And then -3, 0, 2, and 5. These are a piece of cake, right? That's why we're kind of just running through them together. Now, when you get the mapping notation, then that's already set up for you in order and everything. You can just copy the numbers down. So we get -2, -1, 0, 1, and 2. Those are my x's, and then my y's are 0, 1, and 4. Now, I'm going to change the directions on the next one just a little bit. We are going to, it says to give the domain and range of each relation in set notation, we are going to use inequality notation instead, so that we have an example of that. So my domain, what is my smallest x value going to be? -infinity. So I'm going to go from -infinity. This is inequality notation, so I got my inequality signs here, and then to infinity. For range, what's my smallest y value? -infinity. Oops, sorry, I'm leaning. I work so hard on not being a leaner on the board, and I still do it. Okay, -infinity. Y to what? 6. And do I include 6? Yes, I do. So that should be less than or equal to there. All right, so number 5, that my x's start at -3. Do I include it? Yes, because it's solid. Then I go to infinity, and I never include my infinities. Y, I've got -4 to infinity. All right, so number 6. I know I'm starting out here at -infinity for my x's. -infinity. And then as I'm going along here, what's happening right here to my x values? Or what's happening right here? What do I have? I have an asymptote. I'm going from -infinity. I never actually make it to 3, right? And then I start over here on the other side of 3, but 3 is not part of it because I have an asymptote right here. Okay, so since I never actually get there, I go from -infinity to 3, but I'm not including it. But then I got to keep going on the other side of 3. So when you're doing inequality notation, you connect the 2 with the word. So this is going to be and. And then I'm going to do mine sideways because I've run out of room. And so then I'm going to start back over at 3, which is less than x, which is less than infinity. So you might have to turn your head sideways if you need to read that. So for my range, I'm starting down here at -infinity, which is less than y. I'm going to go all the way up, and then what's happening here at the x-axis? Not for inequality. Inequality, it should be a word. So less than, what's happening here at the x-axis? It's another asymptote. So we have a horizontal asymptote as well. So we're never actually going to get to 0. And then it's going to be and 0 is less than y, which is less than infinity. Okay? We good? Any questions so far? All right. So let's look at the back. So now this says to give the domain and range an interval notation. So this time we're using interval notation. This is the one we're going to use the most. On this graph right here, I don't know if you can really tell that these are arrows, but they're arrows. That's why when I was shrinking these, I was stressing out because they're kind of hard to read the size they are. They were going to get smaller. So domain. So what's my smallest x? negative infinity, and then I go all the way to infinity. So I'm using commas here because this is interval notation. And then that's when I have to decide on parentheses or brackets, but my infinities always have parentheses on them. Then I go to the range. So my lowest or my smallest y value is what? Negative 5. Ooh, I'm leaning again. Dang it. Negative 5 to what? 5. And then these would be brackets, yes. So then let's look at, we're going to do domain of number 8, and then I'm going to let you work on some of these on your own. But so at number 8, I got a hole in my graph. We're going to end up with a whole lot of holes and other weird things in our graphs here. But so I'm going to start with my lowest x value being negative infinity. Actually, I'm going to move it over a little bit. I have negative infinity, and I'm going I go, and then bam, I go to negative 1. I know I don't include my infinity. Do I include my negative 1? No. And then I got to start back over. So here's where you use the symbols. You either use the U for union or the upside down U for intersection. Which one is it? Union or intersection? Okay, union, because that's the union of the two intervals. The intersection would be what they have in common. And we don't want what they have in common because they don't have anything in common. So it's the union of negative 1 to infinity. We good? My infinity looks weird. Okay, so what I want you to do is I want you to complete number 8 and then do 9 through 12 on your own while I pick up the papers and a couple of other little things, then we'll talk about them, okay? All right, who wants to give me number 10? Not everybody at once. Volunteer on something you know, because I just might call on you on one you don't know. Okay, negative infinity to infinity, parentheses on both sides. Negative. Okay. Do y'all agree with that? Anybody disagree with parentheses here? Because the person that answered this last period for me put a bracket there. Do you see why maybe they would have put a bracket there? Can you really tell 100% that it's an asymptote? Do you kind of feel like that's probably the intention? Yeah, and it is the intention, and so this is correct, but in certain situations, you would have more information to be confident that it was an asymptote. So, I mean, right now we're just kind of looking at pictures and doing some things, but that is an asymptote there. And actually, on my board, it looks like it almost goes below it, but still an asymptote. So, good job. All right, number 11. Who wants to help me with number 11? I'm not calling somebody I don't know. Let's see. Where's Trinity? That's you. All right, come on, help me with number 11. And it's okay to be wrong. If I'm not saying you're wrong because you haven't said anything, but don't be afraid to be wrong because I'll help you through it. What do you think for domain? Where do we start? Okay. And what do I put all around them? Like, is there a bracket here or what? Okay, and over here? A bracket, okay. And then what? Okay, yes, if you want to keep going, all right. Okay. Okay. So let's talk about this just a little bit because this is like 99% right. Now, if you put the bracket, what does the bracket mean? You're including it, right? So if you're including it, you don't have to break it. Does that make sense? What we really need to do here is leave it out because that's where your asymptote is, right? So that's why we have to break it. If I wanted to include it, then I could really just go from negative infinity to infinity. Does that make sense? So right here, what should I really have, Trinity? Parentheses, very good. But do you understand why? Because that is the part that's confusing, because that's what Douglas said. That's hard. That's what's hard about this sometimes is knowing if it's supposed to be brackets or parentheses. But are you good on why it's parentheses? Everybody, we're good? Okay. I'm sure you're only one thinking that or confused about it anyway. That's why we're going through this anyway. All right, good job. All right, so Trinity, can you help me with the range? What are we doing here? Okay, so tell me, what's your smallest y? Okay, good. Negative infinity. And then if I'm here at negative infinity, what's I keep going. Nothing stops me, right? To infinity. Good. Very good. Okay, everybody good with that one? Any questions? All right, who wants to give me 12? Anybody? Be brave. Come on. It's the second day of school. Okay. 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 Why did you second guess yourself? Because of the hole? Okay. Very good. Because now, be honest, because I've had different answers than this today too. How many of you either weren't sure what to put or tried to break it up because of the hole? Anybody thinking that way? Okay, good. Thank you for being honest, because I know you're not the only one. Now, we're right. This point right here does not exist. So that point, which is it -4, -3? This point, which is -4, -3, doesn't exist right here, right? But I don't break up my range there because, remember, your range is the set of all possible y values. Well, whatever this y value is here, it shows up twice for two different x's, right? So I don't have a -3 y value here, but as I come back around here, it gets picked up right there, so it actually is part of the range. Does that make sense to you? EJ, it is the second day of school, boy. Sit yourself up. All right, we good? Any questions? All right, let's talk about functions real quick. Functions. A function is a special type of relation. Okay, so a function is a relation. All functions are relations in which each element of the domain is paired with blank, blank element of the range. Right? And so when you think of domain, you should think in terms of x's, and when you think of the range, you should think in terms of y's. Even though they could be something else, that's the kind of thing that pops in your head. That's good. So every x is paired with what? What goes in the blank? Only one, or I'm going to use a different word, but only is fine, but it's exactly, it means the same thing. Really, either one of them is fine. But exactly one element, or only one. But somebody last period said at least one. It's not at least one, because it's only one, or exactly one, something that refers to that. Okay, because you can repeat either x or y, but not both of them to be a function. What are you allowed to repeat? The y, okay? So we're going to determine whether or not these are functions just based on that. And so here, each x is paired with one y. There's only one of each, so that one's really easy, and then the answer is just yes, that's a function. What about 14? Is that a function? No, because this -9 uses two different y's, so that's a big no. It's a relation, not a function. What about 15? Yes. Now the 8 repeats. Is that okay? Yes, because y can repeat, x cannot. Then we have something called the vertical line test, which some of you may have been taught. The pencil test is the same thing. Your teacher was just telling you could use your pencil to run across here. But a vertical line, we're also going to have a horizontal line test that we do. I don't think you've done horizontal line tests before, but right now we're just concerned with vertical line tests. But if a vertical line intercepts a relation at more than one point, it is not a function. So the vertical line test, if I can drop a vertical line down anywhere along the function, and I should only hit along the graph, I should only hit it one time each, that means it's a function. So that's yes. All right, so let's look at 17. If I drop a vertical line, what do you think? If I drop the vertical line, like right there, I hit the graph twice, which means no, it is not a function. And then on 18, there is an asymptote here, okay, so there's not anything here. It's not like they both end up going to -1. So I can still drop a vertical line down anywhere and only hit the graph once each time, which means yes, it is a function. So very easy to tell graphically, especially when you have nice, pretty clean graphs, and then also understand how the x's and the y's go together.